here's where I'm at. The reason I brought out inverse trig is because I've got theta as the subject. And I want to work out d theta on dr directly. Okay. Now, by the way, even though you're like, oh, gross, derivatives of inverse trig, number one, you still need to know your derivatives of all the inverse trig functions when you do that topic, right? So you can't avoid it. And secondly, as you see when these results come out, there are actually some ways in which it's kind of neater than when we took the reciprocal and had all these trig functions in our derivative. Okay. So let's have a go. Let's just think of the basic case when you've got cos inverse of x. Okay, what's the derivative? What does it look like? Cos inverse is the one that's dropping down, so it's like this. Okay, so that tells you the sign of the derivative will be negative, right? So it's minus something. Okay, now at this point you sort of need to just use your memory, okay? So it's 1 over the square root of, does anyone remember what comes next? Because I'm just using x, just regular x, it's 1 minus x squared. Okay? I was so close, okay? And of course when you're doing sine inverse, it's just positive, okay? Anyway, so if that's my derivative for just cos inverse of x, here you've got to be careful, okay? Because not only is it inverse trig, it's also chain rule, okay? So you've got 3 over r in there. I'm going to have to differentiate that, and then I'm going to need to know the derivative of 3 on r. What's the derivative of 3 on r? This is 3r to the power of minus 1, right? So it's minus 3 on r squared, okay? I'm just putting that on the side so that there's less in my brain when I'm actually doing chain rule, okay? So now, I think that's enough. Let's give this a go, okay? I'll differentiate the outside, which looks like this, okay? So I've got minus 1 over the square root of 1 minus, now it's not x squared, is it? Because I don't have an x, I've got 3 over r, okay? So it's going to be 9 over r squared. Do you get that? It's 3 over r all squared, okay? So there's my derivative of the outside. Now I plug in the derivative of the inside, which is just that. I worked that out already. Okay. Alright, so I can tidy up just a little bit. I can put that as a 3. Now at this point, I suppose I could put this into the underneath the square root. It'd be the square root of r to the 4, but I'm not going to bother, to be honest, because I'm about to evaluate all these numbers anyway. It's not dramatically simpler. So I'm going to go r squared 1 minus 9 over. Okay. So there's the theta on dr. I can sub that in here now, right? So I know what dr and dt is. It's just minus 2. So if I multiply that by minus 2, I'll get minus 6. R squared 1 minus 9 over r squared. Okay. And by the way, just compare this to what you had before when we got to d theta on dt. The theta on dt, sorry, okay? What was it? There were like cos thetas and sine thetas. Why does this look so different? So drastically different. It's the same d theta on dt. Why is it different? How can one derivative, the same derivative, we calculate it one way and we get trig functions in it, and we calculate it another way and there are no trig functions? How does that work? Thank you. This d theta on dt, same derivative, but it's all in terms of r's. It's in terms of a length, okay? You don't do trig ratios on lengths, okay? But before, our derivative was in terms of theta. So that's why we had coses and sines. There's my derivative. I don't want the general one, I want it at a certain point. Namely, as we worked out before, when r is equal to 5. Okay? So when r is equal to 5, d theta on dt is minus 6 on okay? Now, by the way, can you see, this is why some people would like to use your inverse trig, actually, because I don't have to go back and forth between what's r and what's theta, I just plug my numbers straight in, okay? So minus 6 on, sorry, that's just 25 times, what's this, 25 on the square root of 16.5, which is minus 6 times 4 over 5, this 5 and that 2, this 4 becomes 2 and this 6 becomes 3. Is it looking familiar? it's minus 3 over 10 radians per second. Okay? So, in terms of raw numbers of lines, they're pretty close, actually, I think. I mean, they occupy about the same amount of space on the board. The trickiest part, I think, is just remembering what the derivative of your inverse trig functions are. If you do that and you don't mess up your chain rule, it comes out not too badly. Okay? So you can use inverse trig for these questions. Wherever you've got angles involved, you've got both choices. Okay? Unless they say to you, use inverse trig, and then you have to do this.